Hey y'all, this is part 2 of the Lockbox problem, and the textbook will be in the description. So I'm just going to jump right back in. We were on the constraints for this problem. And so our first constraint is that each region must send its payments to one city. So that's all summarized right here. So basically we sum over the cities for each region. So when we are doing it for each value in a set, we want to start off with a loop for that set. So we're going to say for I in region, because it's for all regions. It's that for all symbol that you see in linear programming problems. If you see that, that means you're going to have a loop, you're going to start with a for loop, and then to sum over things, which again is our x that we're summing over. So summing over the cities, we just have our x pairs, and this is indexed with I and j, so we have in brackets and parentheses I comma j, and that is for j in city, and that is all except equals 1. We want that to equal 1 for each region. And then let's see, our next constraint is it is for all, basically this is going to tie together our x and our y. So it's saying that if we want to send from region 1 to city 2, then y2 must be 1, because we can't send to, let's say, we can't send to Chicago if we don't have an operation center in Chicago. So this just ensures that these two variables are linked together. So we're going to say, if you look here, I'm going to zoom in a little bit. So I'm going to zoom in, or zoom out first, but if you look down here, we have a summary of every single constraint. Of course, we're not going to sit and type that all out because we don't need to. We can use for loops. But these for loops are going to be a little different than normal. Usually we have one at the top and one in the same line as our summation. But if you look, you can see that this constraint must hold for every single city in every region. So it's not just like for all cities or for all regions, it's for all cities and all regions. So we want to start with for I in region, colon, and then another loop for j in city. And we're going to have our equation line using we do prob plus equals. And this is going to be x on the left-hand side, so x vars. Remember, we have two subscripts, and must be less than or equal to our y variable for j, because y only has our j subscript for cities. And again, we don't need another loop right here because we already have our loops for both of our subscripts right above. So for all cities and for all regions, this equation must be true. And then finally, I'm just going to double check. So we have our 0 or 1, and this is LP binary for both, and we have all that correct. So I'm going to do the printing a little bit different than normal because I want it to look nice and I want it to be clear what our solution is. So I do want to print the status right now just because I feel like it. So LP status is what we use to show that this is our optimal solution to this problem. So now I'm going to make a loop that says for j in city, if the value that the solution gives us, I had different decision variable names when I did this problem before. So I guess this would be for our, if our x variable, x vars, actually, that's our y variable, my bad. If our y variable with the subscript j, and then we have to put dot var value, is greater than or greater than 0, then we'd like to print this line. And I said lockbox operation. So we know that we're going to be operating in that city if our value is greater than 0. So then the other loop for other variables are is for I in region, and for J in city, since this X variable has 2 subscripts. Again, that's why we have 2 loops. We are going to print, we have to say our conditional statement, if X bears I comma J is greater than 0, what we're going to do is print send payment to comma J. So that's going to print our city J from I comma region. And you can do this the other way around if you want to say from region I to a city J. Feel free to do that. So I also want to say, I'm going to say city. Didn't do that before, but it probably makes more sense. And then of course we have our optimal value. So let's say total annual cost, and that's minimum. And that also needs to have value prob.objective. So now we are going to go ahead and run this and see if we get the right answer. Lockbox 2 LP variable. Of course I spelled this wrong. Greater than, not supported. So it looks like down here, forgot to put var value. And here's our solution. So we see that it's optimal, and the way we printed this, we can easily say a lockbox operation in LA and New York. And I'm going to just show you that this is the correct solution. So down here it says, just says, oh, this is the wrong page, I think. No, for the, right here, my bad. So Y1 is Los Angeles and New York, it says right here, and then West customers should send to LA, and all other customers should send payments to New York. So you can see that all the other regions are sending to New York, and our minimum total cost is $242,000, and that is how you solve the lockbox problem. And I hope this video was helpful and you're able to follow along, and check out my next video for more linear programming in Python. Bye!